All right. In our next section, we're going to talk about limits now. We said we would dig into that, and we are. This section talks about the limit laws. Our textbook we're using really loves to get into the nitty gritty of this. A lot of these things are in that kind of a, well, duh, I mean, kind of a thing. So I don't want to spend too much time going into things that are kind of obvious. Sometimes we get a little bogged down in that. So let's talk about the first rule. The first rule is this one, that if I just have an x here, and I say the limit as x approaches some number a of just an x, it's going to be a. An example would be, what's the limit as x goes to 4 of x? It's just 4, right? There's nothing magic. It's just kind of, yeah, we get it. Okay. The next one is the same thing. If this is a constant, not x, then whatever this value is doesn't matter because we're talking about a horizontal line. So the limit as x goes to a of some constant c is just that constant. So for example, the limit as x goes to -2 of the number 4 is just 4. That doesn't change. And here, you can read this in a text or on the internet. I'm just not going to waste time writing all this. I'm just going to explain it to you. There's the sum and difference rules, which just say if I have the limit as x goes to a of two functions that I'm adding together or subtracting, then you can just evaluate them separately and then put the answers together. You can either add them together or subtract if it's a difference thing. There's nothing magic about it. If there is a constant multiple, in other words, if I have a constant times a function, and I want to find the limit, I can pull that constant out in the front, evaluate the limit, and then multiply the constant by the answer. I think that's fairly straightforward as well. Product quotient, the same as the sum and difference. If I have two functions being multiplied, I can evaluate them separately and then multiply the answers together. Same thing with the quotient. Just remember, though, we can't divide by 0. That would be the only restriction there. There's nothing magic there. And then powers and roots. If I have a function to a power and I want to find the limit, I can find the limit of the function, then raise the answer to the power. Same thing with the root. I can take the answer, and if it's to a root, then I can just take the answer and put it to the same root. So very straightforward, nothing strange going on there. And we'll have a whole bunch of examples of this. All right, a couple of examples to look at. So here is the limit as x goes to -3 of 4x plus 2. Again, we're just plugging this in, and you can think about them separately if you want to. You don't need to. So I simply plug that in. 4 times -3 is -12, plus 2 is -10. Down here, here's a whole bunch of things all happening together. There's the constant, there's sums and differences, there's the quotient. Again, we just evaluate the whole thing and get an answer. So plugging in -2, 8 minus 6 plus 1, 8 plus 4, and I get 1/4. And same thing down here. Plug in the 3, and we get 23 over 24. Very straightforward, my friends. Okay, now what we're going to do is we're going to look at the challenging versions of limits, and we're going to look at some techniques for dealing with those. The very first technique is probably your least favorite, which would be factoring. So we're going to look at some examples of that right now. So let's look at this step by step. So here's our function. Limit as x goes to 3 of x squared minus 3x over 2x squared minus 5x plus 3. Step 1 is always evaluate. Just plug that number in to see what you get, because we don't know what we need to do until you've evaluated it. You might get lucky, win the lottery, and you actually get a number here, like 2 over 3 or 1/4 or whatever, and then you're done. You're literally done. That is just not going to happen hardly ever, and mostly it's going to be either something over 0 or, in this case, 0 over 0. And so then when that does happen, then what's going to happen is that we need to factor out the thing that made this go to 0. What made it go to 0? Well, it's this x minus a, meaning the limit as x goes to a, whatever that a is, that's the thing that made this go to 0. So in this case, it's this 3. That 3 is what is making this whole thing go to 0. So we need to factor out x minus 3. That's the factor we're bringing out. So then you're going to go up here and use your factoring techniques. So I see I can pull an x out of there. So I get x times x minus 3. And down here I can pull out a 2x plus 1 and an x minus 3. And notice if this is 0 over 0, you are going to get that same factor in both. You must. Okay, that's just a requirement. And then the next step would be to cancel those out, get rid of those. And so here's what you get. And then from here, we start the process all over again, right? You reevaluate. Now, later on, when you get to be advanced, you might have to do this again because you might end up getting, oh my goodness, it's 0 over 0 again. And just keep going. You'll learn some more advanced techniques for dealing with that later on. But right now, in this case, look, we got a number and we are done. The answer is 3/7. Let's check out another one. Here's x going to approaching -3 of our function. We evaluate, plug it in. We get 0 over 0 again. So our factor is, because that's a -3, the factor is x plus 3. Pay attention to that, right? Because it's x minus a. Okay. And so then we factor out x plus 3. Here's the factoring work. Cancel those, and I'm left with x plus 1 over x minus 3. And then we reevaluate. And I get 1/3. Pretty straightforward. That's the factoring technique. All right, we just reviewed factoring as our one technique. Now we're going to do conjugate multiplication as another technique. This is very specific. When we have, usually we have a radical sign like this somewhere hanging around here, and it kind of gets in the way of us trying to be able to factor. So for example, let's just look here. So I have the limit as x goes to -1. Notice when I put -1 here I get the square root of 1, which is 1. 1 minus 1 is 0 in the numerator, and then of course 0 in the denominator. So I still have my 0 over 0 form, but I can't factor it. So since we can't factor, but I do see this radical sign there, I'm going to go ahead and do the multiply by the conjugate. So usually we have a radical plus or minus something else is kind of a clue. Doesn't always work that way, but it's a good clue. So what the conjugate is in this case, it's this term. I have a radical with something in it, -1. So the conjugate is the same thing, only +1. So it's like going to turn into a difference of squares is what it's going to do for us. And so then when you multiply this, you see it's two binomials. And so when I FOIL it out, those inner terms disappear. That's why I put the plus here. That's why these are opposite terms, so that inner term disappears. Multiplying the radicals together just gives me the whatever was inside the radicals. So in this case, x plus 2 minus 1. So when I reevaluate that, notice I get x minus 1. So in this case, that becomes the numerator. Now, I would advise you not to deal with multiplying out this bottom here, because you know it already sits. Here's the canceling factor. If you were to FOIL this out, you might lose the ability to see it. So just check it out here. And whatever you are conjugating, whatever you're doing the conjugate on, just leave it there and see what happens. So let's see in this case, I can see there's something to cancel. So we're going to go to our next step, which is to cancel. And now I'm left with this, and now I can reevaluate, and my answer is 1/2. Let's look at one more example of that. Upside down. Upside down. So the limit as x goes to 5 of this. Notice when I put 5 in here, 5 minus 1 is 4. Square root of 4 is 2 minus 2 is 0. 5 minus 5 is 0. I get the 0 over 0. Can't factor, so we're going to do the conjugate. Here's what I'm multiplying the conjugate by. So this is the part I'm going to deal with. Leave the denominator alone. And so then I do that, and my numerator turns into x minus 5 after I do my FOIL. Notice I didn't do anything to the bottom. I just am dragging it down because these are going to cancel, right? Just leave it alone. And when I cancel, I get this. Then go ahead and reevaluate. What's the limit as x goes to 5? And oops, I didn't write that here. I'm going to put the limit as x goes to 5. And the answer is 1/4. All right, the last of our basic techniques here is the complex fractions technique. That's more algebraic than anything else. Obviously, I think if you see a complex fraction, you would know, oh, something's wrong here, I need to fix it. And the way we do that is Here's an example. Limit as x goes to 1 of this mess. So what we do is we see that there's fractions in the numerator or fractions in the denominator. Obviously, first we check to make sure, yes, this is 0 with 0. So then we fix the fraction by multiplying by whatever denominators are giving you grief. So in this case, I do not want fractions in the numerator or fractions in the denominator. So I'm going to multiply the entire fraction, the whole thing, by whatever these are. So in this case, it's 2 and x plus 1. So I'm going to multiply the top by 2 times x plus 1 and the bottom. And that way, at least this will get taken care of, and then we can look at it again. So let's see how that works here. So I'm going to multiply by 2 times x plus 1 over itself to make it 1, right? So we're not changing the value. So when I multiply this x plus 1 and that x plus 1 are going to cancel, so I'm left with 2. So 2 times 1 is 2. That's where that comes from. This minus is that minus. We just bring it down. And then I'm multiplying this whole thing by 1/2. This 2 and that 2 we're going to cancel. And then I'm left with 1 times x plus 1, which is x plus 1. The bottom right now, I'm just going to leave alone because, again, we're probably going to have to factor something. So I'm not going to multiply this out. Just leave it there for just a second. Because it wasn't the bottom that was giving us grief. It was the top that was giving us grief. So this is 2 minus x minus 1. So that's negative x plus 1. Now, here's where some of my friends might get a little bit of heartburn. You'd say, well, I don't see this down here. Well, you need to factor out a negative 1. So if I factor out a negative 1, this becomes negative x minus 1, and then you do see it down here. So here we go. Here's our step 3. I can cancel these, right? Cancel those with each other. And then what I'm left with is going to be negative 1 in the numerator over 2 times x plus 1, and then you can reevaluate. And then I get negative 1/4. All right, let's look at one more. Here I have 1 over x plus 2 plus 1 over x plus 3. We're going to negative 3. Check, and I get my 0 over 0. Use my complex fraction technique. In this case, I just have the one thing. So I'm going to multiply by x plus 2 over x plus 2. And then this becomes a 1. Oh, oops. Oh, I did that wrong, my friends. Yikes. This is 1. This should be a 1 here. So this whole thing's wrong then. I was not paying attention when I was doing this. So this is 1 plus x. So we're going to fix this on the fly here. And then x plus 3 times x plus 2. So then this becomes, so this is wrong here in the numerator. This becomes x plus 3, right? So this is 1 plus x plus 2. And then the x plus 3's cancel. I had wondered why that was, because in my, when I did it the first time, it ended up being dne. And I'm like, that's not right. The problem shouldn't do that to you at this stage. So let's go back and recompute. So it's 1 over x plus 2, which looks like 1 over negative 3 plus 2 is negative 1. So the answer is negative 1.